This is the ICSE Council Specimen Question Paper for Chemistry, that is Science Paper 2 of 2025. The time is 2 hours. As you know, Section A has 40 marks. Now, this paper ICSE Council has given, they are the most important papers. You must understand not just the questions, but the type of questions that are asked. Okay, so I'm not going to solve each and every question. I'll just tell you the thinking behind it. Yeah. So question 1, if I have aqueous solution of copper sulfate turns colorless on electrolysis, that means I do not have copper anode, I have platinum anode, and cathode will have to be copper. So you look at the options and you can get the answer straight. Let us look at the second one. Compound P heated in the test tube with sodium hydroxide solution, and red litmus paper is held at the mouth of the test tube. It turns blue, which means the gas is alkaline. Now, if I have alkaline gas, only one gas is alkaline in your syllabus, that's ammonia. That means ammonium hydroxide is formed. So which one is ammonium over here? That's your choice. Which of the following would weigh the least? 2 grams of oxygen, 2 gram atoms of oxygen. Now oxygen 1 gram atom is 16. So 2 gram atom will be 32. 1 mole of sodium is going to be GAM, that is 23 gram. 22.4 liters of carbon dioxide at STP will be 44 grams, because that will be 1 mole, and this is 0.1 mole of carbon. 1 mole of carbon is 12, so 0.1 will be 1.2 gram, which is the least 1.2. Okay, let's come to the fourth one. Equation below shows the reaction between element X and a dilute sulfuric acid. So we have this reaction taking place. Which particles are responsible for conducting electricity in dilute sulfuric acid and compound XSO4? This is aqueous. This also is aqueous, which means in the electrolyte it is because of the movement of ions. Now, can they be only positive ions, only negative? No, it will be both of these. So electrons is totally out of the question. Assertion A, dry hydrogen chloride gas is collected by upward displacement of air, because hydrogen chloride is heavier than air. So this is true. But they say that it is lighter than air, which is false. So you choose which option. I'm not giving you the answers. I'll just tell you how to think. 4 hydrocarbons are given here. How many isomers of butene are there? Now butene over here, this is not butene because there's no double bond. There's a double bond here. So this is the first carbon, second carbon. And then if you take a straight chain like this, it is a bent chain this way. So it will be 1, 2, 3, and it will be 2-methyl butanene. Now can you see over here? This is 1, 2, 3, 4, and this is normal butene. Now this one over here, this and this, isn't it the same? Tell me. First carbon has double bond, second carbon has methyl group. First carbon has double bond, second carbon has methyl group, and this we can bring it up here. It becomes exactly the same. So there are 2 isomers. P has electronic configuration 2881. That means it is P1 plus valency. Number of chlorine atoms in the chloride of it will be 1 only. Correct? Because Cl is 1 minus, P is 1 plus. This is the isotope of hydrogen in the periodic table. In the periodic table, as long as the atomic number is the same, it will be placed in the same place. Okay, so it will be placed before, after, no, same position as hydrogen, yes. Nitrate, which forms a precipitate with ammonium hydroxide and is also soluble in excess of it. So we have the cation which will dissolve in excess of ammonium hydroxide when it forms the hydroxide. Now in ammonium hydroxide, we have only Zn2 plus and Cu2 plus which are soluble in excess. So which forms a precipitate and is soluble in excess of it will be copper, because zinc I cannot see anywhere. So it will be this option. Which of the following electronic configuration represents the most electropositive element? Most electropositive will be in group 1A and at the bottom. So group 1A is this, not this, so it will be B. Assertion: alkali metals do not form di-positive ions. Alkali metals are in group 1A, so they'll have one electron in the outermost shell, which will be lost, making it monopositive ions. So after the loss of one electron, alkali metals will achieve stable electronic configuration of noble gases is correct. So one electron is given out, so how can it be di-positive? So assertion is false and this one is true. No, alkyl metals do not form di-positive means it is true, it will form monopositive. Sorry, this is true and this also is true and it's the correct explanation. Ratio between volumes of 4.4 grams of carbon dioxide and 2 grams of hydrogen. Both of them are gases. 4.4 grams means zero point 0.1 mole of carbon dioxide and 2 grams of hydrogen is 1 mole. So it will be 0 point 0.1 mole to 1 mole means 1 upon 10 is to 1. So 1 is to 10. That will be option C. Think about how we can go about this. 13th one, aqueous lead nitrate can be distinguished from aqueous zinc nitrate by adding any one of the following solutions in excess except. So there is one which cannot distinguish the two. Now let us look at this potassium chloride. If potassium chloride is reacted with lead nitrate, it will form lead chloride, which will be a white precipitate. But zinc will not give you a precipitate because zinc chloride is not a precipitate. Aqueous sodium sulfate with lead nitrate will form lead sulfate, which is a white PPT, but zinc nitrate will give zinc sulfate, which is not a PPT. So I can distinguish lead from zinc nitrate. Dilute sulfuric acid will with this give me lead sulfate, which will be white PPT, but zinc sulfate is not a PPT. So I can use even this to distinguish. And sodium hydroxide will give me lead hydroxide here and zinc hydroxide here. Both of them are white PPTs and both of them are soluble in excess of sodium hydroxide. So I cannot use this. So I cannot use this means that is the one that they are looking for. So correct option is D. Which of the following about oxides is correct? Basic oxides, oxide of a non-metal. Basic oxide is that of a metal, so this is wrong. Acidic oxides contain ionic bonds. Acidic oxides are formed from non-metal. Then the non-metal and non-metal will not give me ionic bond, it will give me covalent bond. Amphoteric oxide contains a metal, yes, because amphoteric oxides are with Zn, Al and Pb, so which is correct. And basic oxides are always gases. Basic oxides are the oxides of metals. Are metal oxides gases? Never. Non-metal oxides are gases. Okay, so the correct option is here. You need to know all the theory behind it properly. Now look at your 15th one. We have these many different strips. They are in 4 different test tubes and he adds 10 ml of freshly prepared ferrous sulfate solution in each of these. And they are saying what would be the test tube number to have black residue in the test tubes. Now remember, copper is below iron. So if I have FeSO4, copper will not displace that Fe because copper is placed below iron. So you need to know your activity series by heart, and you have to know how to use it effectively. This copper will remain copper only. It will not have black residue. But aluminium will, with FeSO4, displace Fe, and Fe will be settling down here, and that will be grayish black in color. This is iron, and we place iron only in that, iron sulfate. So iron sulfate will not have any reaction done. This also will be black. And zinc over here with FeSO4 again will displace Fe, and zinc will go in the solution, and Fe will be settling down here, that will be black. Now in reality they will be second, third and fourth. These three will be having black residue, but here they have given only second and fourth. So that is the correct option over here. In reality this also should have been added. That finishes our first question, question number 2. Now, can you see over here? This is step 1, step 2, step 3. Even in question 1, we saw electrolysis. So, prepare electrolysis very well and understand in each case what is going to happen. If I'm coating with copper, then coating with nickel, and then I'm coating with silver, then the first diagram over here is going to show you this, which is the cathode connected to the steel object which is to be coated, and this is copper anode, because copper anode will take part in the reaction. Now they are saying the chemical process taking place on the surface of the object is this. What is the observation on the surface of the object? This copper will get deposited on this, so pinkish brown or reddish brown deposits will be seen on the object. That's the observation. Explain why the concentration of copper ions in the electrolysis remains constant. That is because the copper ions which are discharged at the cathode as neutral atoms, they are replaced by a copper atom losing electron and becoming ion. So the concentration of copper 2 plus ions in the electrolyte remains the same. You'll have to write it down properly, underlining the keywords. What changes would be needed to coat nickel onto the object in step 2? If I want a nickel coating, can I use copper? Here I cannot. It will have to be nickel, and here it will have to be nickel sulfate or nickel chloride aqueous solution. These are the two changes. We come to write down the reaction taking place at the positive electrode during step 3. Positive electrode is here, and for the step 3 we are going to coat it with silver, so this will have to be silver. So silver takes part in the reaction, and the electrolyte being silver argentocyanide solution, and this reaction at the anode will be Ag minus 1 electron gives you Ag1 plus. So can you see these ones are important questions? Here can you see you have to know the definitions and aluminum, how it is connected. Know this thoroughly. Metallurgy should be done properly. Now an element 1 electron in the outermost shell is periodic table. Know your periodic table very well. 1 electron in the outermost shell, that means it is group 1a. Group 1a will have larger atomic size. So this will be the largest atomic size. Sulfuric acid, hydrochloric acid does not form an acid salt. Hydrochloric acid has only one H, so it cannot be partially replaced. So it will be hydrochloric acid. Here, reddish brown, dirty green colored precipitate. When we have ferrous chloride reacting with this, ferrous means 2 plus, means it will be dirty green. So see, this is your analytical chemistry. You have to emphasize on the colors of precipitate and the solubilities in excess. This is organic chemistry. If they are alkynes, they are triple bond, means they are unsaturated, which means addition reaction. And alkaline or acidic solution will turn methyl orange from pink to red. Remember, it is orange to pink to yellow. That is the change in color. So if it is going pink, then it is acidic solution. You have to know the color change of all indicators well, know it by heart. Identify, mostly these are the definitions. Can you see that? These are all definitions. Organic chemistry is there, the bonding is there. Can you see this is acid, basis, salt? These ones all definitions. They will not ask you directly, they will ask you identify. Look at the structural diagram. Propanoic acid is prop means 3 carbons, oic acid means COOH group. Learn the structures of the organic compounds and also their IUPAC name. It is pentane 2 all, which means 5 carbons will be there, second carbon will have OH. I'm not going to write that, I'm just giving you the thinking process behind it. 2,2-dibromobutane. But means there are 4 carbons, and 2,2-dibromo means the second carbon has got one bromine up and one bromine down, and complete all 4 carbons with their 4 valencies. IUPAC names. Here, can you see? Look for functional group. What is the functional group here? All. Alcohol it is. So it is propane 1 all. What is the functional group here? Double bond. So it is alkene. So it is 1, 2, 3, 4, 5. So it is pent 1 in. Can you see that? Get through all the IUPAC names, the different examples that are there in the book as well as the last year's papers. Look at all the questions. Now let us come to section B. Look at the questions that are here. There is the reactant we have to identify, and the balanced equation when the nitric acid is reacting with Q gives a salt CaNO3 twice water and carbon dioxide. If it is giving calcium nitrate, then the reactant must be having calcium as a cation. And if it is liberating carbon dioxide, that means it must be having carbonate as the negative radical. So it will be CaCO3 plus HNO3 dilute, and you complete the reaction. Understood the thinking behind it. What property of sulfuric acid here? Sulfuric acid has got 6 properties. Know each property and know the example reaction for each one of them. Preparation of HCl gas when it reacts with sodium chloride is non-volatile property. It's a non-volatile acid. Concentrated sulfuric acid reacts with copper to produce sulfur dioxide, is where this is an oxidizing agent. Let's come to the third one. Electron affinity of element X is greater than that of Y. For this you will have to do a little bit of thinking. Maybe you'll have to write on the paper. This is connected with periodic paper. Electron affinity increases across the period. So if X is having greater, X is on the right of Y. The oxidizing power of X, whatever's on the right side is an oxidizing agent. So oxidizing power of this will be more than Y. The electronegativity is more on the right of the periodic table, so this also will be more than Y. And X is likely to be placed on the left or on the right of Y. Y you have on the left side, so X is on the right side. So that finishes our third part. Now, fourth part, you are provided with a list of chemicals. You can see the list of chemicals that are there. You have to write the balanced chemical reaction. I'll just tell you how to think. Now, this is copper and sulfate. Copper and sulfuric acid, if I take, that reaction is not possible because copper is below H in the EC series. So, for copper, I will have to take not copper but maybe copper oxide, hydroxide or carbonate. Can you see over here copper carbonate? So here you'll take copper carbonate, and for sulfate you can take dilute sulfuric acid. So copper carbonate will get decomposed with dilute sulfuric acid. It will give you copper sulfate. Write the reaction as CuCO3 plus dilute H2SO4, and you know how to write the reaction. It is just one day before your boards. Sodium zincate. If it is sodium zincate, you must have zinc to react with here. Is there zinc over here? Yes, there is only zinc. But if I want sodium zincate, I must have the compound with sodium, which is sodium hydroxide. This being amphoteric, it is going to give us Zn plus NaOH will give us sodium zincate plus H2. Then you just balance the reaction. Ferric chloride is Fe plus Cl2 direct combination or synthesis. So is there iron? Yes. Is there chlorine? Yes. So 2Fe plus 3Cl2 gives you 2FeCl3. That is the reaction. Number 4, extraction of aluminium. Now here, learn the full metallurgy of aluminium. It's important. Learn the Bayer's process, the 3 reactions. Learn the Hall-Herold's process. Everything you should know, which are the compounds which are added to the electrolyte when we are having electrolytic reduction of aluminium oxide, the alumina. Okay, so all that. Now let us come to this. He heated Pratik. 11.2 grams of element M, atomic weight is 56, 4.8 grams of element N. This is given to form a compound. Find the empirical formula of the compound. Now, can you see normally empirical formula means we are given the percentages. Are they given the percentages? No, they've given you the masses. So when there are masses, total mass this plus 4.8. 11.2 plus 4.8 is 16. Yes. So the percentage of M in that is 11.2. I'll just show it to you. 11.2 upon 16, and that multiplied by 100. That will be the percentage of M. All right. Now 16 goes 7 times in this. So 16 goes 0.7 times. So that gives us 70% of M. So obviously N, which will be 4.8 upon 16, that will come out to be 30%. So percentage of N is going to be equal to 30%. And then you make the columns like how you make for empirical formula, molecular formula, and you will get the answer for this. I am just teaching you how to think, not to panic. That's important. Give balanced equation for each of the following. Warm water with aluminium nitride. This is nitride used for making ammonia. There are 3 nitrides. Do you remember which ones they are? Ca3N2, Mg3N2 and ALN. All these 3 reactions are important. Learn them by heart. These are important questions. Oxidation of carbon with concanitric acid. Concanitric acid will make carbon become CO2 and it will give H2 and NO2. Learn to balance the reactions. These reactions are important. Even with copper, nitric acid, they are important reactions. Laboratory preparation of ethanol using chloroethane and aqueous sodium hydroxide. Now this also, if you have learned organic chemistry properly, you will be able to do it. But if you are stuck for whatever reason, they are saying we are preparing ethanol, we are using chloroethane. Chloroethane means ethyl group is C2H5 and Cl, and we are taking NaOH, which is aqueous, and then we have here boil. So aqueous NaOH is going to give you alcohol. How? It is going to go this way. So it will be C2H5OH and plus it will be NaCl. So that will be our reaction. So you see, what are the important questions, how to tackle them? This is very, very important. Let's come to the 4th one. Nitric acid preparation, Oswald's process. And the process has ammonia oxidation chamber. So here we have NO becomes NO2, NO2 becomes HNO3 here. So that's how we get HNO3. Write the temperature and catalyst required during catalytic oxidation of ammonia. Now remember, the ammonia catalyst is going to be platinum. Temperature is going to be 700 to 800 degrees. These are again important reactions. Learn both the reactions. In presence of catalyst and in absence of catalyst, both oxidations are important. Give balanced equation for the reaction in the conversion of nitrogen dioxide to nitric acid. We have 4NO2 plus 2H2O plus O2 gives 4HNO3. In that chapter, that reaction is written so many times. You should know that by heart. Question number 5. Ranjana wants to prove ammonia as a reducing agent. To demonstrate, she passes it over copper oxide. What will she observe? This black copper oxide is going to become copper because oxygen will be removed. What is the color of copper? Pinkish brown or reddish brown deposits of copper. That's what she will see. Write the balanced chemical equation for the above reaction. Now, this reaction and PBO reaction with reducing property of ammonia, you have to know both by heart. Okay, learn it up if you haven't. Then there are two more reactions reducing property of ammonia they will show, and that is ammonia in excess with chlorine and ammonia with excess chlorine. All those four reactions you must know by heart. These are important. Name the alloy made with this and this. This is simple. This is bronze. This is your solder metal. Abhishek was given salt X, white in color for analysis. Strong heating, he had yellow residue. Yellow residue must be the PBO, or yellow when hot and white when cold means ZNO. A colorless gas means oxygen, and reddish brown gas means NO2. That means this X must be a nitrate. The solution X, when tested with excess ammonium hydroxide, it will form chalky white precipitate insoluble, is confirming that it is Pb2 plus. So this yellow residue was PBO. Name the colored gas is nitrogen dioxide. Which cation was present? It was lead 2 plus. Identify the salt, it is lead nitrate. In this, you will see this is your Hall-Herold's process. You should know the suspended carbon rods. They are the anodes. What is the electrolyte? You must know in what ratio, by volume or by weight. These are important things. What is this? This is the cathode. What is the cathode made of? And you will be having no problem handling this. X forms an oxide with the formula X2O3. That means X is valency 3 plus because oxygen is 2 minus. So X3 plus, where will be, in which group it will be? Na is 1 plus, Mg is 2 plus, Al is 3 plus. So definitely it will be with Al, it will be in the same group. Justify the answer just now. I told you, you write it elaborately and mark the keywords. Let us come to the student was asked to perform two experiments based on the instruction. Observe the picture given below and state one observation for each experiment 1 and 2 you would notice on mixing the two solutions. Experiment number 1, there is a test tube containing zinc sulfate, and this over here is test tube containing solution of barium chloride. The zinc sulfate solution, the moment it comes here, this sulfate will be taken by barium. Barium sulfate means white PPT will be formed of BaSO4, that is insoluble in dilute HCl. So that would be the observation. Now let us look at your experiment 2, test tube containing ammonium hydroxide, and here test tube containing precipitate of copper hydroxide. Now copper hydroxide with ammonium hydroxide, copper hydroxide is blue in color, but when you add ammonium hydroxide more, it will give me inky blue solution, correct? Copper solution is electrolyzed using copper electrode. This has been repeated twice in this paper. So remember, aqueous solution of copper sulfate electrolysis is important. Go through this, important it is. X and Y are two elements. Which one will be the metallic element? The one which will have 1, 2, 3 valence electrons. So Y. Metal atoms tend to have maximum of Bla electrons in the outermost shell. It is 1, 2 or 3 electrons, then they are metals, so 3. And Bla is the reducing agent. All metals in group 1A, they lose electrons and supply that electron to the non-metal, reducing them. So all metals, they are reducing agents. So which one is a metal here? Why? Question number 7. Household fuel has propane 60%, butane 40%. 20 liters of mixture is burnt, find the total volume of carbon dioxide added to the atmosphere. The combination reaction are given here. Now, they have not given you directly how much is propane and butane here, but they tell you total is 20 liters. Now, 60% of 20 liters will be 60 upon 100 into 20, means it will be 12 liters. 12 liters of propane means ये 12 liters है. And remaining 8 is 40%, so this is 8 liters. All these are gases. Use Gay-Lussac's law. Find the volume of carbon dioxide here, carbon dioxide here. This will be 1 volume is to 5 volume, gives you 3 volume is to 4 volumes by Gay-Lussac's law. This is 12 liters, so this will be 12 3 is 36. You have to show the working. I'm just showing you the thinking that goes behind it. So you will have 36 liters here. For this, there is 8 liters is 2 volumes, so 1 volume will be 4 liters. 8 of these will be 8 4 32. So 36 and 32. Total, how much of CO2 will be there? Add, and that's your answer. This one again is a very popular and important question depending upon the pH. pH 2 means it is strong acid. So X is strong acid. 7 means Y is neutral, and this means it's a strong alkali. Which one of them will liberate SO2 from sodium sulfite? It has to be an acid. Which is the acid? X. Which will liberate ammonia gas from ammonium chloride? Ammonium chloride reacted with a base, reacted with alkali with OH, will liberate ammonia gas because it will form NH4OH. Which one of them will have OH? Not 2, not 2 because it's acid. 13 will be what? It will be alkali. You're with me? Then which will have no effect on the litmus paper? Obviously the one which is neutral, that is why. Okay, we come to 8.2 grams of calcium nitrate is decomposed using this reaction. What is the volume of nitrogen dioxide obtained at STP? Now out here, if they are telling you this is 8.2 grams, so you have to find GMM of this. So 2 into the GMM is going to give us volume. Here the volume of NO2 they are saying how much, and mass of CaO it is how much. So you got to go from this quantity to this quantity. So you will say that if 2 into GMM is going to give you 4 into 22.4 liters, then if it is 8.2 grams, then how much volume will be liberated? Okay, so that is your answer A. For B, what will you do? This mass is required, so you have to know the GMM of this also. Now 40 and 16, 56. So this is 2 into 56 grams. So 2 into this, I don't want to work it out, but you know how to find GMM, right? So 2 into this GMM will give 2 into 56 grams of CaO. So if it is 8.2 grams, then how much? Okay, so this and this also is doable. Please learn chemical equations. If you found this a little confusing, just revise that, because how much self-study you do, that is going to help you. So chemical equations are important. Gay-Lussac's law is important. Of course, you all are going to do everything, but remember what is important. Now give reason. Zinc and aluminium can be distinguished by heating the metal powder with concentrated sodium hydroxide solution. Give reason if. Can you distinguish them? Both of these are amphoteric. So zinc with NaOH will give us H2 with sodium zincate, and aluminium will also liberate H2 giving sodium aluminate. Both of them are going to give H2, that is colorless odorless gas, which extinguishes the glowing splinter with a pop sound. So can you distinguish them? No. So what is the answer? No, since both will liberate hydrogen gas, and so we cannot distinguish. Now look at this. Can we distinguish between calcium nitrate and lead nitrate by adding ammonium hydroxide? Now ammonium hydroxide is a weak alkali. Will it give precipitate with calcium cation? No. But with lead, can it give? Yes. So it will be white precipitate for lead nitrate. lead hydroxide will be formed, which will be insoluble in excess, and calcium nitrate will not give any precipitate. So can you distinguish? So write yes and then mention the reason. Electron dot diagram for ammonium ion, hydronium ion, hydroxyl ion, all time hot favorites. These are important questions. Balance chemical equations. Remember, ethyne preparation is important. This is acetic acid to ethyl acetate. This is esterification along with the condition is important. Laboratory preparation, nitric acid, HCl, your Oswald's process, all the reactions, contact process, all the reactions, everything is important. Please learn it properly. Look at these 6 organic compounds which are given. Identify 2 compounds which are the members of same homologous series but not isomers. Homologous series means it will be your double bond also. This is a double bond, this is a double bond. What is this? Is it a double bond? This one is carboxylic acid. What is this over here? This is dash OH. Don't say it is CHO. No, it is C and OH. So this is your alcohol. This is oic acid. This is alkane. This is alkane. And this is alkene. So which ones are the uh, homologous series? This one, alkene here, and this one. Identify 2 of the compounds which are the members, so A and F. You can say this is alkene and this is also an alkene. Which 2 compounds are isomers of each other? Isomers of each other is 1 2 3 4, 1 2 3 4. Can you see? This is a branch isomer, chain isomer. This is, that is your C and E. F can be prepared from D. Where is F? Yeah, from D. So this is your ethyl alcohol and this is your ethene. Preparations of ethene, also for preparations of alkanes, CH3COO plus NaOH, and in presence of CaO. Remember those decarboxylation reaction, those ones are important. Also the preparation of alkyl halides. From that, if you prepare alkene and and uh, alkyl halide to uh, alkyne and also alkyl halide to alcohol. Okay, those preparations are also important. Now, can you see we finished everything? These are the answers. So you saw the thinking that goes behind these. ICSE has been very kind enough to send one specimen paper like this so that you know which are the most important questions. Think along those lines and do your best, study everything well, and do yourself and your parents proud. All the best for your examination. Bye.